Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey Herman and Corn, we talked about how sometimes it really is the small details in life that make the big differences. We had an interesting episode yesterday about the Israel's supply of interceptor missiles, Tamir, and the absolutely amazing logistics that are involved in the operation, or might be involved in the operation. And speaking of small details, I'm currently looking at my computer screws. I got a little box of them because I am on a mission this year, never to have any repair project blocked by not having that screw. And it's kind of a weird one actually, because you can buy these little screw kits. I'm trying to get the monitors on the Visa mount, which I need a rivnut apparently, a rivet nut. And I do not have a rivnut nor a rivnut fastening tool. So at the moment it's kind of ad hoc, but I feel like very soon I'll be done with all my repairs and back to my workstation. But I want to make sure there's nothing more frustrating for those who are working on computer repairs and stuff like that, to have everything except the machine screw or the M screw that you need for your project. And I'm currently identifying them with the help of AI, which is a great use case for anyone who hasn't stumbled upon it. If you've got a good camera with good macro performance, and especially if you have a calipers on hand, you can actually go through your screws and identify them with a very high degree of reliability. I found a screw website in Israel that'll distribute anywhere in the country in a couple of hours, which tells me that other people have the pain point of missing the exact type of screw. It said they have an inventory of 50,000 types of screws and fasteners, which really tells you the absolutely crazy amount of these tiny pieces that exist. And when we're talking about being able to repair things quickly, which we've talked about in the context of Israel's self-reliance doctrine, this stuff actually matters. I'm not talking about getting my Visa mounts up on the wall, but little things. No one wants to be derailed from installing anything from these little small components. What I'd like to chat about today, specifically Herman and Corn, for those who, like me, are on a mission to have a well-stocked screw box, so we never get to this point in the first place. If we're doing electronics repairs, we're going to come across a few things over and over again. You've got the M series, if you will, or the M sizing for screws, M2, M3, M4, M5, M6, etc. You've got UNC 632 is a different standard. And these different families of screws, nuts, bolts, rivets, rivnuts, they all have slightly different families, if you will. In other words, if you're involved in repairing laptops, you're going to need some M2s, if I can recall. If you're involved in repairing desktops or doing work with desktops, getting them onto motherboards, you're going to need some 632s. And for Visa mounts, I believe the typical standard is M4. So Herman and Corn, let's go through the little things, the little nuts and bolts, literally, that make our electronics work. If one wanted to build up, and how did the professionals do it? Because you see these videos, I feel like everyone who's involved in desktop repair or electronics repairs has just kind of built up a collection of standoffs, screws over time. I guess some of it is just ad hoc. The particular challenge of it, at least here in Israel, is that some of these parts are really, really obscure. So the natural place to buy them from is AliExpress, and it actually makes a lot of sense. But they take like 3 weeks to come. So because the lead time is kind of frustrating, there's a strong reason to actually try to think about it proactively and make sure you have all the things you need and maybe even a few more, so that they're ready in your workbench before you're working on the next project. Herman and Corin, let's talk about the little screws in our tech stuff in today's episode of My Word Prompts.
You know, Herman, I was thinking this morning about that old proverb, the one about the missing nail. For want of a nail, the shoe was lost. For want of a shoe, the horse was lost. For want of a horse, the rider was lost. It goes all the way up to the downfall of a kingdom. It feels a bit dramatic when you are just trying to mount a computer monitor, but in the moment, when you are finally at the very end of a project and you realize you are missing one tiny 5-cent piece of metal, it feels like the kingdom is definitely crumbling.
Oh, I have lived that proverb more times than I care to admit, Corn. It is the ultimate anticlimax. You have spent hours researching, you have got all the main components laid out on the workbench, you have invested the money, and then everything just stops. You're ready for the victory lap, but you are tripped up by a missing fastener. I am Herman Poppleberry, and I have spent a significant portion of my adult life digging through old jars of mismatched hardware, praying to the gods of logistics that I will find one specific thread pitch in a sea of rusted wood screws.
It is a universal experience for anyone who likes to tinker, but today's prompt from Daniel takes it to a whole new level of intentionality. Daniel is on a mission to never let a repair or a build get blocked by a missing screw again. He is currently working on mounting some monitors, and realized he needed a very specific thing, a rivnut, and a special tool to install it. That really highlights just how specialized these little things can get once you move beyond the basic Phillips head.
A rivnut. Now that is what I call a deep cut. Most people go their entire lives without ever hearing that word unless they are doing some serious automotive fabrication or high-end industrial mounting. But it is such a perfect example of how the right fastener makes the difference between a professional grade setup and something that just feels flimsy and temporary.
We are going to dive deep into the world of fasteners today, specifically in the context of electronics and home labs. Daniel mentioned something that absolutely blew my mind. There is a distributor there in Israel with an inventory of 50,000 different types of fasteners. 50,000! When you think about a screw, you think, okay, it is a metal bit with some threads and a head. How on earth do you get to 50,000 variations?
It sounds like an impossible number until you start breaking down the variables, and then you realize 50,000 might actually be a conservative estimate for a major distributor. You have got the diameter, the thread pitch, which is the distance between the threads, the length of the shank, the head style, the drive type like Phillips, Torx, or Hex, and then you get into the materials. Zinc-plated steel, stainless steel grade 304, stainless grade 316 for marine environments, black oxide, brass, nylon, titanium. If you change just one of those variables, it is a completely different part number.
And in the context of electronics, which is our focus today, those variations are not just aesthetic, they are deeply functional. If you use the wrong screw in a modern laptop, you are not just looking at a loose hinge. You might literally pierce the lithium polymer battery or short out a trace on the motherboard. The tolerances in a MacBook or a Dell XPS are measured in fractions of a millimeter.
Exactly. We should really dive into what I call the big three families that Daniel brought up in his prompt, the M series, the 632 UNC, and the specialized stuff like those rivnuts. Because once you understand the taxonomy of these things, you stop seeing them as just screws and start seeing them as specific engineering solutions. It is like learning a new language.
Let us start with the M series, the metric screws. Daniel mentioned M2 through M6. For most of our listeners who have ever opened up a laptop or a small gadget, M2 is basically the king of the hill, right?
Absolutely. M2 and its slightly beefier cousin, M2.5, are the bread and butter of portable electronics. The M stands for metric, and the number tells you the major diameter in millimeters. So an M2 screw is exactly 2 millimeters across the threads. When you are looking at a modern, ultra-portable laptop, space is at such a premium that every tenth of a millimeter matters. If you look at the internal layout of a phone or a tablet, they are often using M1.2 or even smaller.
I have noticed that even within the M2 family, the length is where people get caught out. You see a screw in your junk jar that looks exactly right, but it is 5 millimeters long instead of 3 millimeters. In a laptop chassis, that extra 2 millimeters is a mile. I have seen people dimple the palm rest of their laptop because they put a long screw into a short hole and kept turning until the plastic started to bulge on the other side.
It is a heartbreaking mistake to make, and it is not just the length. In laptops you often see what we call wafer head screws. These are incredibly thin, flat heads designed to sit almost flush with the surface because there is no clearance for a standard rounded head. If you try to replace a wafer head with a standard pan head screw, the laptop case might not even snap back together, or worse, the head of the screw will press against the back of the screen and cause a dead spot on the LCD.
That is a great point. And then you move up to M3, which I feel like I see more in internal components of larger devices. For example, mounting a 2.5-inch solid-state drive into a bracket or a mounting sled.
Spot on. M3 is the standard for those smaller drive mounts and many internal optical drives, if anyone still remembers what those are. But then things get really weird when you move over to the desktop PC world, because suddenly we are not using metric anymore. We are using the 632 UNC.
That one always felt like a total outlier to me. Why is the desktop PC world so dominated by this weird imperial measurement, while everything else in the tech world is moving toward metric? It feels like a relic of a different era.
It is a total legacy thing, Corn. It goes all the way back to the original IBM PC in the early 1980s. The IBM PC established the standard, and because so much of the manufacturing infrastructure for PC cases and power supplies was built around American imperial standards at the time, it just stuck. The 6 refers to the gauge of the screw, which is about 0.138 inches, and the 32 means 32 threads per inch. It is the unified coarse thread.
It is funny because you will have a computer where the case panels and the power supply use 632 screws, but the motherboard standoffs might be M3. It is a total linguistic and engineering mishmash inside a single machine. You need 2 different sets of tools and 2 different mental models just to change a motherboard.
It is a nightmare for organization. If you accidentally force a 632 screw into an M3 hole, you are going to strip those threads instantly. They look almost identical to the naked eye if you are just glancing at them in a dimly lit room. This is why Daniel's idea of using AI with a macro camera is actually brilliant. It solves a problem that has plagued hobbyists for 40 years.
Let us talk about that for a second. Identifying a screw visually is notoriously hard. You can tell it is small, but telling the difference between a 0.4 and a 0.5 thread pitch just by looking at it, that is nearly impossible for a human without a magnifying glass and a lot of patience.
It really is. Even professionals often use a thread pitch gauge, those little metal folders with sawtooth edges to verify. But we are in February of 26 now. The computer vision models we have access to are incredible. If you have a high-resolution macro photo, an AI model can actually count the threads against a known scale and calculate the pitch. It is a perfect use case for computer vision because it is a purely geometric problem. There is no ambiguity.
I imagine you would need a reference point in the photo, though. You can't just take a photo of a screw in a void and expect the AI to know the scale. You would need a coin or a ruler in the shot, right?
Ideally, yes. Or even better, a pair of digital calipers. If you have the calipers in the shot, the AI knows exactly how many pixels represent 1 millimeter or 1/10 of an inch. From there, the math is trivial for a machine, but a huge time saver for a human. It turns a guess and check process into a measure and confirm process. It removes the crunch factor. That horrible feeling when you realize you've just cross-threaded a screw because it was the wrong pitch.
So, we have M2 for laptops, 632 for desktops, and then Daniel mentioned M4 for VESA mounts. That is the standard for monitors and television brackets. Why the jump to M4? Why not stick with M3?
Weight and shear strength. A 27-inch monitor or a 55-inch television is a lot heavier than a circuit board. M4 gives you that extra thickness, 4 millimeters, that can handle the tension and the shear force of a heavy display hanging off an articulated arm. If you used M3, you would be much more likely to have a screw snap or the threads fail under the constant stress of moving the monitor arm around. For really large TVs, you even see M6 or M8.
That makes sense. Now let us get to the boss level fastener Daniel mentioned, the rivnut. For those who are not familiar with fabrication, how would you describe a rivnut to someone who only knows standard screws?
Okay, think of a rivnut or a blind rivet nut as a way to put a threaded screw hole into a piece of material that is too thin to be tapped. Imagine you have a thin sheet of metal like the arm of a monitor mount or a car body panel. You cannot just drill a hole and screw into it because the metal is only a millimeter thick. There is not enough meat for the threads to grab onto.
Right. It would just strip out the moment you applied any torque.
Exactly. So you drill a hole, insert the rivnut, which looks like a hollow metal tube with threads on the inside, and then you use a special tool, a rivnut setter, to crush the unthreaded part of the tube against the back of the metal sheet. It mushrooms out and creates a permanent threaded insert that is locked in place. It is like a heavy-duty wall anchor, but made of steel or aluminum and designed specifically for metal, on metal applications.
That is fascinating. So Daniel is essentially upgrading his mounting hardware by adding these threaded inserts where they did not exist before. That is some serious pro-level DIY. He is not just using what came in the box. He is re-engineering the mount to be more robust.
It really is. But it also requires having the specific tool. You cannot just install a rivnut with a screwdriver or a pair of pliers. You need a setting tool that applies a massive amount of linear force to collapse the sleeve without stripping the internal threads. This brings us back to Daniel's main point. If you do not have that specific tool and that specific size of rivnut, the whole project stops dead. You are stuck with a half-mounted monitor and a very frustrated afternoon.
This leads perfectly into the self-reliance doctrine that Daniel mentioned. Living in Israel, there is a very specific cultural and logistical context here. Israel is often described as an island economy. You are at the end of a very long supply chain. If you need a specific, obscure fastener, you have two choices. Find a local specialist who happens to have it in stock, or order it from overseas and wait.
And waiting, in that context, usually means 3 weeks for an AliExpress package to clear customs and arrive at your door. In a professional environment, or even just for an enthusiastic hobbyist who has finally found a free Saturday to work on a project, 3 weeks is an eternity. It kills the momentum. It turns a fun project into a chore that sits on your desk, mocking you.
I think there is a psychological component to this too. Daniel talks about the well-stocked screw box. When you have that, you feel empowered to fix things. If you know you have the parts, you are more likely to open up that broken monitor or try to reinforce that shelf. If you know every repair is going to involve a 3-week delay and a search for an obscure part, you just don't do it. You throw the device away and buy a new one.
It is what I call the friction of repair. We talk a lot about right to repair in terms of software locks and specialized pentalobe screws, but a huge part of it is just availability of fasteners. If a manufacturer uses a proprietary screw, they are intentionally adding friction to the process. But if you are proactive, like Daniel, you are essentially building your own right-to-repair infrastructure in your own home.
Which is why I love the idea of a proactive collection. But Herman, how do you actually manage 50,000 types? Or even just the 50 most common types? If you just throw them all in a jar, you are back to the jar of chaos. And you are spending 3 hours looking for one screw.
Organization is the secret sauce. It is the difference between a hoarder and a librarian. Most professionals use those grid-style organizers, the ones with the little removable bins. But the real pro tip is labeling them with the specific specs, M2.5, 5mm, Phillips, zinc. You don't just label it small screws.
I have seen some people actually tape a sample screw to the outside of the bin so they can see exactly what is inside without even opening it. It gives you a tactile and visual reference immediately.
That is smart. Another thing is having a replenishment system. This is where the industrial side comes in. When you use the last of your M3 standoffs, you have to have a way to remind yourself to order more before the next project starts. It is basically mini logistics for your home workshop. In a factory, they use what is called a two-bin system.
Tell me about the two-bin system. How does that work for a home user?
It is simple but brilliant. You have 2 bins of the same part. You only pull from the first bin. When that bin is empty, you move the second bin forward and you immediately place an order for a refill. That way, you are never actually out of a part while you are waiting for the replacement to arrive. For someone like Daniel, who is dealing with 3-week lead times from overseas, a 2-bin system is the only way to maintain sanity.
It reminds me of how hospitals manage their inventory. It is all about safety stock. Maybe that feels like overkill for a home office, but If you are someone who relies on your gear for work, a missing screw is a downtime event, and downtime is expensive.
Honestly, for the cost of these things, it makes sense to buy in bulk. You can buy a box of 100 M3 screws on a site like AliExpress or even a local industrial supplier for about the same price as a small bag of 4 at a big box hardware store. If you buy the 100, you are set for years. You become the person that your friends call when they lose a screw. You become the local fastener hub.
I want to go back to the Israel context for a second. Daniel mentioned that distributor with 50,000 fasteners. It is interesting that in a small country you have these hyper-specialized pockets of industry. You might not be able to find a specific screw at the local neighborhood hardware store, the tambour shops as they are called in Israel. But if you know where to look in the industrial zones of Tel Aviv or Haifa, you can find anything.
It is a very insider type of knowledge. You have to know the name of the place, and you usually have to show up in person and talk to someone who has been working there for 30 years. Someone who knows the difference between a grade 8 bolt and a grade 12.9 bolt just by the weight of it in their hand. It is a very different world from the polished aisles of a modern retail store.
And that is where the self-reliance comes in. It is about building a map of where these resources are. But even better than a map is having the resource on your own shelf. Daniel's mission is really about autonomy. It is about not being dependent on a global supply chain for a 2mm piece of steel.
Exactly. And let us talk about why someone would need 50,000 types. We have talked about diameter and length, but what about materials? Why would I need a nylon screw instead of a steel one?
I assume that is for non-conductive applications. If you are mounting a circuit board and you do not want any risk of a short circuit if the screw touches a trace.
Precisely. Nylon is great for that. But then you have the opposite problem, heat. If you are in a high heat environment, nylon will melt, so you need brass or stainless steel. And then there is the galvanic corrosion issue. If you put a stainless steel screw into an aluminum frame in a humid environment like, say, a coastal city like Tel Aviv, you can actually get a chemical reaction that welds the screw into the hole over time. You need to know which metals play nice together.
It is amazing how much engineering is packed into something so tiny. We take them for granted because they are everywhere, but the world would literally fall apart without them. I mean, think about the vibration resistance. In a car, or even a desktop computer with high RPM spinning fans, screws can eventually back themselves out.
That is why we have things like lock washers or nylon insert hex nuts, often called nylock nuts, and of course, dreadlocking compounds like Loctite. Daniel mentioned nuts and bolts too. There is a fundamental difference in how they handle stress. When do you choose a bolt and a nut over just a screw into a tapped hole?
I would guess it comes down to the material you are joining. If you are joining two pieces of metal and you can get to both sides, a bolt and a nut is almost always stronger, right?
Usually, yes. A bolt and nut allow you to apply a specific clamping force. You are squeezing the two materials together. A screw relies on the threads in the material itself, which can be a weak point, especially in softer metals like aluminum or in plastics. This is where the rivnut is such a clever hybrid. It gives you the clamping strength of a nut, but it stays permanently attached to one side so you can use it like a screw hole. It is the best of both worlds for thin materials.
So, if a listener wants to start their own Daniel-style proactive screw box, where should they start? What are the must-haves for a modern tech-literate person in 26?
I would say start with a metric assortment. Get a kit that has M2, M2.5, and M3 in various lengths, from 3mm up to maybe 12mm. That will cover 90% of your small electronics repairs. Laptops, controllers, small appliances.
And for the desktop PC builders, or the home lab enthusiasts?
You need a dedicated bag of 632 UNC screws for the case and power supply, and some M3 screws for the internal drives, and honestly, a handful of motherboard standoffs. Those things are like gold when you are mid-build and realize you are one short. Also, don't forget the M4 screws for VESA mounts. If you buy a monitor arm and it doesn't come with the right length for your specific monitor's recessed holes, you'll be glad you have a box of M4x12 and M4x16 screws.
What about the drive types? Are we strictly a Philips head world now? Or should people be looking at hex and Torx?
Philips is still the most common, but it is actually a pretty flawed design by modern standards. It was originally designed to cam out, meaning the screwdriver slips out of the head if you apply too much torque. That was a feature in 1930s auto manufacturing to prevent over-tightening. But in modern precision work, we actually want more control, which is why Torx, that six-pointed star shape, is becoming the standard for high-quality electronics. It doesn't slip, and it allows for much more precise torque application.
I have noticed that Apple uses those tiny pentalobe screws, which is a five-pointed star. That feels like a very deliberate attempt to keep people out. It is the ultimate gatekeeper fastener.
It absolutely is. You cannot find a pentalobe driver at a gas station or a local grocery store. You have to seek it out. But once you have a good precision bit set like the ones from iFixit or some of the newer modular sets we've seen lately, you feel like you have the keys to the kingdom. It is about removing the barriers. The screw is the gatekeeper. If you have the right driver and the right replacement screw, the gate is open.
It is about autonomy. And it is not just about repair. It is about customization. Daniel is mounting monitors. Maybe he wants to use thumb screws so he can adjust things without tools later. That is a choice you can only make if you know what thread pitch you are working with. You can't just wing it with a thumb screw.
You know, we have talked a lot about the technical side, but there is a real sensory satisfaction in the click of a perfectly fitting screw. When the threads catch smoothly and it tightens down with just the right amount of resistance, it is very grounding. It is a tiny bit of order in a chaotic world.
Oh, I know exactly what you mean. It is the opposite of the crunch. When you use a mismatched screw and you have to force it, you feel that crunchy sensation of the metal deforming. It is stressful. You know you are doing permanent damage to the device.
The crunch is the sound of a project becoming 10 times more difficult, because now you have to figure out how to extract a stripped screw, which, by the way, is a whole other topic. Screw extractors, left-handed drill bits, the rubber band trick. But the goal of being proactive, like Daniel, is to avoid that nightmare entirely. If you have the right screw, you never have to force it.
I think there is also something to be said for the macro camera and AI approach for documenting a teardown. If you take a photo of every screw you remove, you are much less likely to end up with that one extra screw at the end of the project.
That is a classic, the bonus screw. It is usually a sign that you missed a crucial internal support or a grounding strap. If you are using an AI tool to identify them as you go, you can basically create a digital manifest of the device. Screw A went in hole B. Some of the newer AI-assisted repair apps are actually doing this in real time now. They overlay the screw locations on your phone screen as you look at the device.
It makes me wonder if, in the future, every device will come with a digital fastener map. You could just scan the QR code on the back of your TV, and it would tell you exactly which M-series screws are inside and where they go. It would save so much guesswork.
Some companies are actually starting to do that. They print the screw specs right on the circuit board next to the hole. You will see a little M2x3 printed in white ink. It is a small detail, but it makes the device so much more repair-friendly. It is a sign of respect for the person who will eventually have to fix it. It says, "We know this won't last forever, and we want to help you keep it running."
It is the opposite of the planned obsolescence mindset. It is an endurance mindset. And I think that is what Daniel is tapping into. He is building a library of parts that ensures his technology can endure, regardless of what the global supply chain is doing.
We have covered a lot of ground today, from the 50,000 types of screws in an Israeli warehouse to the physics of the rivnut and the history of the IBM PC. What is the main takeaway for someone who isn't quite ready to buy 50,000 fasteners?
I think it is to stop treating screws as an afterthought. Next time you take something apart, really look at the fastener. Is it metric? Is it imperial? What kind of head does it have? Get a pair of digital calipers. They are $20 and they will change your life. Once you can measure a screw, you can master it.
Once you can measure it, you can master it. I like that. It turns a mystery into a known quantity. It takes the magic out of it and replaces it with engineering.
And maybe start that screw box, even if it is just a small organizer with the basics. The first time you save a project because you had that one M3x6 screw in a drawer, you will feel like a genius. You will feel like the master of your own domain.
I am definitely going to look into getting a rivnut tool now. I do not have a specific use for it yet, but just knowing it exists makes me want to find something to mount to a thin sheet of metal. Maybe I'll finally get those solar controllers mounted properly in the shed.
Just be careful, Herman. Once you start proactive fastening, you start seeing everything as a potential mounting project. Your walls will be covered in monitor arms and custom brackets before you know it.
There are worse fates. But honestly, this discussion has made me realize how much of our modern world is held together by these tiny, precise decisions. It is not just a screw. It is an M2.5, 8mm, Torx drive, stainless steel engineering marvel.
Well, I think that is a perfect place to wrap up this deep dive. Daniel, thanks for the prompt. You have definitely inspired me to go organize my junk drawer and turn it into a proper fastener library. It is time to stop digging and start organizing.
And if any of our listeners have their own fastener success stories, or maybe a fastener nightmare involving a stripped screw and a looming deadline, we would love to hear about it.
Absolutely. And hey, if you have been enjoying the show, we would really appreciate it if you could leave us a review on your podcast app or a rating on Spotify. It genuinely helps other curious people find us and join the conversation. We are building a community of tinkerers here, and every review helps.
It really does. We love seeing this community grow and hearing about the weird projects you all are working on.
You can find all our past episodes at myweirdprompts.com. We have got an RSS feed there for subscribers and a contact form if you want to get in touch. You can also reach us directly at show@myweirdprompts.com.
We are available on Spotify, Apple Podcasts, and pretty much everywhere else you listen to your favorite shows.
Thanks for joining us for this episode of My Weird Prompts. I am Corn.
And I am Herman Poppleberry.
We will see you next time.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.